Hello YouTube. Today this is part 4 of the Linux from scratch run through, and what I'm doing is we're up to chapter 5 in the book, and what we're doing is we are cross-compiling a tool chain. Now there's, I think, yeah, so the way the book seems to work is that you have like several chapters and they have a particular, they're like one part of the build, and that part is broken down into different chapters. So what we're going to do is we're just going to have a quick we'll just quickly review this preliminary material, and we'll go from there. So this says this part is divided into 3 stages. First, building the cross compiler and its associated library. Second, using the Cross-Toolchain to build several utilities in a way that isolates them from the host distribution. And the third, entering a chroot environment, or chroot, it's basically change root, which further improves host isolation, and constructing the remaining tools needed to build its final system. Okay. Yeah, this is, yeah, you should always, this is just saying, look, make sure you actually know what you're doing before you run it. I've been doing that throughout the book so far. And this is the next section is a technical introduction to the build process, while the following one represents very important general instructions. So, right, this section explains, right, so this is toolchain technical notes. I briefly had a look at this today, and this says, this section explains the rationale and technical details behind the overall build method. Don't try to immediately understand everything in this section. Most of the information will be clearer after performing the actual build. Come back and reread this chapter at any time during the build process. Right. I do have that actually already opened. The overall goal of chapters 5 and 6 is to produce a temporary area containing a set of tools that are known to be good and now are isolated from the host system. By using the chroot command, the compilations in the remaining chapters will be isolated within that environment, ensuring a clean, trouble-free build of the target LFS system. The build process has been designed to minimize the risk for new readers and provide the most educational value at the same time. Okay, fair enough. The build process is based on cross-compilation. Cross-compilation is usually used to build a compiler and its associated toolchain for a machine different from the one that is being used for the build. This is not strictly necessary for LFS, since the machine where the new system will run is the same as the one used for the build. But cross-compilation has one great advantage. Anything that is cross-compiled cannot depend on the host environment. So yeah, usually they do cross-compilations for like you cross-compile, you compile something for ARM from x86, etc. Or at least I think you do that. I'm not a C++ expert. There's a lot to read here. I'm just going to skim through this while we do it. I'm just going to leave this for the minute. There's a lot here, and I don't think I need to go through all of this, so we'll carry on. Yeah, all this is saying here is basically make sure you follow the right instructions and keep to the same version of the book, okay? Here are some things that you should know about building each package. Several packages are patched before compilation, but only when the patch is needed to circumvent a problem. A patch is often needed in both the current and the following chapters, but sometimes when the same package is built more than once, the patch is not needed right away. Therefore, do not be concerned if instructions for a downloaded patch seem to be missing. Warning messages about the offset or fuzz may also be encountered when applying a patch. Do not worry about these warnings. The patch was successfully applied, okay? During the compilation of most packages, some warnings will scroll by the screen. These are normal and can be safely ignored. Yeah, this is like pretty much in any non-trivial piece of software. There'll be a bunch of warnings. Okay, Discord has been updated. That's great. Wasn't expecting that. These are normal and can be, yeah. C standards change fairly often. Some packages have not been updated. So, yeah, basically, a newer version of compiler will warn about older code, depreciated bits and pieces. That's normal. Yeah, check one last time that the LFS environment variable is to be set up properly. Yeah, so yeah, let's just do that. You can always just do that to make sure this is set. So that is set. When I did this in the last chapter, we've already done this. Yeah, so the build instructions assume that the host system requirements, including symbolic links, have been set properly. Bash is a shell and use. SH is symbolic link to bash. Awk is a symbolic link to Gawk. I think that's correct. USB yak is a symbolic link to Bison, or a small script that executes Bison. I think we went through that in chapter 2 of the book, which was the first video. Here's important. Here's a synopsis of the build process. Place all the sources and patches in a directory that will be accessible from the shared environment. Amount effort sources. We've already done that. So if I do ls sources, yeah, there's all the sources. We got that already. We did that in, I think it was chapter 3. For each package, use top arrow, extract the package to be built. In chapter 5, 6, ensure that you are the LFS user when extracting the package. Yeah, so basically just make sure we're logged in as the LFS user. Yeah, that's fine. Do not use any other method than the tar command to extract source codes. Notably, using the copy -r command to copy the source code tree somewhere else can destroy timestamps in the source tree because the build fill. Okay. Change the directory created when the package was extracted. Follow instructions for building the package. Change back to the source directory when the build is complete. Delete the extracted source directory unless delete. Right, so you need to delete it afterwards. Okay. And now we're in chapter 5 proper. So let's go to introduction. The chapter shows how to build a cross compiler and its associated tools. Although here is cross compilation is faked, principles are the same as a real cross toolchain. Okay. The program compiler in this chapter will be installed in LFS $LFS tools directory to keep them separate from files installed in the following chapters. The libraries, on the other hand, are installed in their final place if they pertain to the system we want to build. Okay. And now we actually get to build stuff in. So we're installing Binutils. It's important that the Binutils be the first package compiled because both Glibc and the GCC perform various tests on the available linker and assembler to determine which of their own features to enable. So basically, it needs this first. It needs these packages first before anything else. So the Binutils documentary recommends building Binutils in a dedicated build directory. Well, that's All right, so let's just follow this exactly to see if it works. Then cd build. Wait a minute, I'm doing this wrong. Right, okay, so I straight away I just ignored the instructions. This is where you make mistakes. So change the cd. All right, so let's go there and we'll go back to this. Guessing this is correct. cd build. All right, so all right, so what does it want me to do then? It wants me to, okay. Okay. Right, so I was being stupid and not actually reading, even though I read it. So what you need to do is you need to tar xf Binutils. And then you actually read it, which I didn't. What you need to do, why have I got this open twice? No, I've got this open twice, have I? Then you cd do Binutils 244, and then you make the build, and then you cd build, and then you run this. So let's take this. And if we look at how this works, now prepare Binutils for compilation. Right, so this so the prefix tells the configure script to prepare to install the Binutils programs in the LFS tools directory. Okay. For cross compilation, this tells with sysroot. So this basically setting it to the where our mount point is. Tells the build system to look at LFS for the target system libraries as needed. Okay. Target LFS target because the machine description on LFS underscore TGD variable is slightly different than the value returned by the config guest script. The switch will tell the configure script to adjust the Binutils build system for building a crosslinker. Okay. So that disables internationalization. G prof ng. So we don't. It basically it's not required. So this is just a C. This is just a flag for the GCC compiler. Makes the linker use the run path tag for embedded library search paths for executables in shared libraries instead of traditional rpath flag. It makes debugging dynamically linked executables easier and works around potential issues in the test suite of some packages. Okay. Enable default hash style equals GNU. By default, the linker will generate both GNU style hash table and the classic ELF hash table for shared libraries dynamic linked executables. The hash tables are only intended for a dynamic linker to perform symbol lookup. On LFS, the dynamic linker provided by glibc package will always be the GNU style hash table, which is part of the query. So the ELF hash table is completely useless. Right, so this is basically disabling something we don't need. I don't know a huge amount about this. I vaguely remember something to do with how this works in C, but it's been years since I've looked at it. So what we want to do is we're going to run this configure. So, all right, that was pretty quick. And then we do make. This is where it actually compiles it. Right, so that looks like it's built. I suspect there's a bunch of files in it. Yep. And then we'll do make install. All right, and if we go back, all right, so we do cd dot and then delete the extracted source directory unless instructed otherwise. Okay. So we're going to be rmm binutils. Right. So that's that done. And then installation of Cross GCC. So this is the GCC package. So this is GCC compiler. GCC requires that GMP, MPFR, and the MPC packages. As these packages may not be included in the host distribution, they will be built with GCC. Unpack each package in the GCC source directory and rename the resulting directories so the GCC build procedures will automatically use them. Okay, so RXF. So I guess this is GCC. Yep. Right, and we CD into GCC. And then we run these commands. So what this is doing is basically finding these packages. So I think we do ls rep. I'm sure there's a better way of doing this, but I'm stupid. Oh, I'm in the wrong directory. Yeah, so what this is doing is it's basically just you cd into GCC, and then you extract each one of these packages into the GCC folder, and then you do the same instructions as before, essentially. Okay. Think I understand what to do. Okay. So we'll do that first. So we'll just go back into the GCC directory, and we'll run this, and this should work. Okay, that looks like it's worked. On x86-64 host, set the default directory for the 64-bit libraries to lib. Well, that's what I am on, so let's do that. In the GCC documentation, recommends building GCC in a dedicated build directory. Okay, so we'll do that. So, and then prepare GCC for compilation. Many of these are the same. So this is the prefix again, the prefix option, the target option. That's a version of Glibc with sysroot LFS. I'm not going to go through every single one of these, but this is just setting a bunch of options for the compiler. This is all of these are doing. Yeah, enable languages C, C++. Okay. So let's run that. We're in build directory. Right, cool. And then we'll compile. So it's always going to be make, configure, make, and then make install. Almost always. Right, so we do make, and this is the compilation step. This doesn't seem to be too long so far, so I think this is reasonable. Right, that is done. So that's compiled. That took a few minutes. So that seems to be GCC compiled correctly. Let's read this next bit. This build of GCC has installed a couple of internal system headers. Normally one of them is limits.h would in turn include the corresponding limits.h header. In this case, LFS USR include limits.h. However, at the time of this build of GCC, that path does not exist. So the internal, that file does not exist. So the internal header that has been installed is a partial self-contained file that does not include the extended features of the system header. This is adequate for building glibc, but the full internal header will be needed later. So this is like, it essentially goes and puts in a temporary version of this file. I'm not sure what this does. I might look this up later. Create a full version of internal header using a command that is identical to what the GCC build system does in normal circumstances. So, right, so we're going to make one. Okay. Okay. So CD GCC. All right, we'll just see what happens. So this looks like it's all right. So it's concatenating these files, and it's evaluating this build directory. Yeah, so basically, it looks like it's basically concatenating these files and outputting the result into this basically this path here by the looks of it. So we just need to copy this. STGT. Right, so if that don't work, so I'll do this. So it's failing on this line. What does that mean? I think it's basically saying it's not there. If we can get some clues. All right. I was hoping there was going to be an easy solution for this. What does dear name do? So what this is doing is, right, so this, right, so it just strips off. What is this? What is this trying to do? This, that exists. So that does what? All right, so that basically cats the file and then outputs it to, so what this, okay, so this puts, this, it just doesn't seem to work. Did I do make install? Let's run this again. I don't think I did. I think I forgot to do make install. Yeah. So I just totally skipped over that. That was a bit of an umpteen mistake. Well, these things happen. This is typical when you're doing anything that's semi-complicated. You will make these mistakes. So try not to make that mistake again. Okay, well, that's complete successfully. So basically, because I did do make install, those files weren't where it was expecting. So this was basically failing. It's a bit of a silly mistake, but this is why I'm doing it sort of like fairly raw. So you can see the mistakes that people typically make, and it was me not following the instructions correctly. A classic. So it's all good. It's all good. Yeah, so once I realised that basically it was probably looking for some files that didn't exist, hand copied things into the right places. That's why that wasn't running. So not particularly entertaining for people, but I was a little bit confused. That's fine. Right, so the next part is we're installing the Linux API headers. So we're going to make the Linux kernel needs to be right. So before we start anything, I'll just keep on typing stuff because it's not quite a set of instructions. So what we need to do, we need to follow these instructions again. So change the directory now. We cd back into sources directory. So cd ... We're back in the sources directory. and then rm minus rf GCC. Probably going to take a while. Okay, that's fine. And then we need to tar xf. What are we building now? We're building Linux, aren't we? The Linux headers. So, oops. Right, so we need to tar accept that. I imagine it's be quite big. Right, there we go. And then we need to cd into that Linux directory. And then, right, so make sure there's no stale files embedded in the package. So make mr proper. Okay. I remember this command from when I had no idea what I was doing with Linux. I was trying to compile a kernel for Slackware so I can have like a frame, like a graphical frame buffer, which was a total waste of time because I got it working and then installed something else like a week later. This is like 20 years ago. Now extract the user visible kernel headers from the source. This is recommended. The recommended make target headers installed cannot be used because it requires rsyncs, which may not be available. The headers are first placed in .usr and then copied to the needed location. Okay, so what does this do? So we make headers. So it runs this make script, and then find USR includes blah blah blah. So, right, so let's just run this. Make headers. Oh, right. So what this is doing, it's finding all the files that aren't a .h file. So I think. So not. I think that's not name h. And then it deletes them. Basically, it just finds a bunch of files and deletes them if they're not a .h. So it's anything in here that's not .h. Almost all of them were, weren't they? Not being silly. Right, let's just not worry about that. Just, I think it's fine. And then we just copy those into this directory, which is the USR directory. Okay. Right, that appears to work. And there's a lot of files it's copied over. So include ASM. That's just, I'm not going to check all of these. I'm just going to do a quick spot check. Yeah, ASM generic. Yeah, this looks correct. DRM. Okay, I think this is good. I'm pretty sure this is good. So that's fine. Net filter. Is there net filter in there? MISC. I'm gonna. there's more, but it does seem to have all of them. So I don't think it's going to hurt. So let's go back. I'm probably... Let's make up net filter. I think this is good anyway, so I'm just not going to worry about this. All right, so we'll just clear that. And then we're going to build Glibc by the looks of it. So we need to go back. So go cd dot dot. And we're going to rm minus rf. The next. Oh. It's fine. And then we're going to it's there. Glibc. Okay. Right. Right, the glibc package contains the main C library. The library provides the basic routines for allocating memory, searching directories, opening and closing files. This is basically all a lot of stuff that it needs. Required disk space is 150 megabytes. Woo, quite big. Right, installation of glibc. First, create a symbolic link for the LSB compliance. Additionally, for x8664, create a compatibility symbolic link required for proper operation of the dynamic library loader. Okay. Okay, this is basically saying, look, this is like, make sure you get the right version of LN installed. Okay. Right, that looks like it worked. So this is basically just made a bunch of symbolic links. Ooh. I screwed up. I did not cd into that directory. So think. I don't think that made a difference. So, oh right, so how does that work? It's got a right. It came out with the same. It linked it in the same way. Did it? Oh right, I'm being dumb. So I think, oh, but there's a cd lib folder in here. So lib. No. We'll run it and we'll see what happens. I find that a little bit confusing, so it's fine. Right, so what we did there, we patched glibc. I didn't read this bit because I kind of read it and then I was still sort of thinking about the other command, which I might have done wrong. So, but I don't think I have because I re-symlinked it. And it does say that you should always cd into the directory first. So as I reran it, it should be good. And so some of the glibc programs use non-FHS compliant, that's file system hierarchy compliant var DB directory to store the runtime data. Apply the following patch to make such programs store the run data in the FHS compliant locations. Okay, well, we just ran that, and then we'll make the DIRs, make the build DIRs, and cd build. LD config, that's something to do with the linker, I think. And there's SLN. So this is just adding this is just writing this set into a file. So so there should be just that file in there, right? That's correct. And then this is the configure. Right, we've already gone through these. Right, so tell glibc to compile the library with support for 5.4 late kernels. Okay, fine. That's those include headers that we just done. Yep. Shows that the library is installed in the USR lib instead of the default lib64 and the 64 machines. Okay. Do not build a name service cache daemon. Okay. Okay, that seems to be just standard configure step. So we'll run that. That was pretty quick. Well, we didn't. I don't think we got that warning. So that seemed to work properly. So this is make again. Generally, what I'm running into here is I know a little bit about building stuff with C and C++. However, there's lots of bits and pieces like the LND comp and other bits and pieces that I'm not quite sure what they do. And I feel like I'm not fully understanding what's going on. But, you know, doing this sort of thing is quite good because it actually exposes what you don't know. And gaps in your knowledge. So I'm going to let that compile. It's going to take a while, I suspect. It's 815 megabytes. It's going to take a while. Right, that was quicker than I expected. So, yeah, I'm not root, and I know that's, so we'll just double check this because it's saying really check this. Right, that's good. And that's why they have you run as unprivileged user, because this could overwrite stuff on your actual system. And then this is the make install step. This time I actually run it. While that's running, meaning the make install option, the dest-dir makes a variable is used. Make variable is used by almost all the packages to define the location where the package should be installed. If it's not set, the defaults to the root directory. Here we specify the package is installed to the LFS directory, okay, which will become the root directory. Yeah, that's when we shoot into it. Fix a hard-coded path in the executable loader in the LDD script. So this is just doing sed. I forget what sed does. Oh, it's a stream editor. Yeah, of course. This looks like it just goes and, yeah, does a find and replace essentially. Yep. Right, oh, here we go. So at this point, it's imperative to stop and ensure that the basic functions, compiler and linking of the new toolchain are working as expected. To perform the sanity check, run the following commands, okay? Let's do that. It's best to make sure it works. If everything is working correctly, there should be no errors, and the output of the last command will be of the form. Yes, that's exactly. So basically, it expects that to be printed out, which is what we got, which is good. Note on 32-bit machines, the interpreter name will be, okay, it will won't have the x64. That's not relevant. If the output is not shown as above, or there's no output tool and something is wrong, investigate and retrace steps to find out where the problem is and correct it. The issue must be resolved before continuing. Clean out the test file. Oh, look, echo main, and then it just compiled this very simple C program. Okay. I didn't actually read it. Read alpha A out. Yeah. So what this does is it compiles it compiles it with GCC. It goes to pipes this and compiles it with the GCC that we just built, by the looks of it, and then it goes and read out. Okay, so what does read elf do? Okay, so and then it goes and reads. Okay, so what this does is it makes this C program. So I think there's an A out somewhere in here. There we go. Yeah. So it compiles this very simple C program, and then what it does, it goes and reads, make sure that that the correct information is in there. That's what that read elf does. Okay. Right. Building the package in next check will serve as an additional check for the toolchain has been built properly. If some packages, especially Binutils pass2 or GCC pass2 fails to build, it is an indication that something has gone wrong, and the preceding Binutils, GCC or gone wrong with the So basically, stuff will not work in the next chapter. If this isn't set correctly set. So go on to the next one. So this is Libstdc C++. This must be the standard C++ library. Yeah, I've done a fair bit of C++ stuff, so I am. This is where I'm more familiar. I actually done more C++ than I've done C, and for most people, it's the other way around, I would imagine. The standard C++ library is needed to compile C++ code. Part of GCC is written in C++, but we had to defer its installation when we built GCC pass1 because libstd++ depends on glibc, which was not available in the target directory. Okay. So what we need to do before we continue is I need a CD out of here, back to source there. Oh. And then rm glibc, right. And then tar xf, so there's libstd. What's it? Is it lib? Why don't I have this? I messed up, have I? I don't actually have this package. So what have I done wrong? Oh, that's AL. Ah. All right. Well, that's fine. So yeah, didn't read it again. Didn't read that bit. So basically, it's part of the GCC table. Okay. So we'll extract it again. Hopefully, we won't have to do the bit we did before, but okay. I don't think we'll need to. So if we do cd GCC and then okay, cd build, and then we build this. So this is again this configure step, disable multi-lib. So I think that disables the 32-bit stuff. Disable LNS. I think we've already gone through that. So right. So this basically says where G++ will live. It should match look. Right. I think this is basically because it tells it where to install. Yeah, this is where it installs the include files. Okay. So the include files are basically, I think, where the standard C++ library files live. So with your compiler, you get and with the standard library, you'll get basically a set of libs that you can reference in the compiler straight off, unless you explicitly disable them. Okay, so that's configure step has yeah, we're in the build directory. That's fine. I was a bit worried I hadn't put. And again, we'll compile. So this is make. And I would imagine this will take a little while. that was very quick. I thought it was going to take a few minutes, a good few minutes. And then make install. Right, so that looks like it's worked. Reference some Python stuff. Interesting. Okay, that's fine. That seemed to work. Remove the libtool archive files because they're harmful for cross compilation. Okay. So it looks like we're just removing some files that's copied over from when we do the make install step. And so they're removed. That looks like that worked correctly. And we're on to chapter 6. So other than me sort of making a few mistakes by sort of either not internalizing what I was reading properly or missing commands, that was like fairly straightforward, if not a little bit lengthy. So this is quite a long video. Hopefully people found this informative, and hopefully I'll see you in the next video, which is chapter 6 of the LFS book. So bye bye.